This is the second lesson on the introduction to trigonometry, where we're going to do some practice problems. So the objective is still the same, that we're going to use trigonometry to find missing sides and angles, and also to use the trig functions. So I'd like you to try this opening, the opening that's on your note sheet. Try the opening of those two problems, pause the video, and then we'll come back and do them together. Okay, now that you've tried it, let's go ahead and take a look at this. So on this triangle, when we talk about wanting to find these trig functions with angle A, the 6 trig functions, you want to first of all relate to angle A. So when we talk about the opposite side is the 12. So what we want to use is an abbreviation that maybe you've used before. It's called SOHCAHTOA, okay? Sine is the opposite over the hypotenuse, that's the SO part. The CA part of SOHCAHTOA is that cosine is the adjacent over the hypotenuse, and TOA is that the tangent is the opposite over the adjacent. So we're going to use that here where the opposite side is 12. Hypotenuse is always the one across from the right angle, so that's over 13. Cosecant is our reciprocal of it. So I just take this fraction and immediately I'm going to just put the reciprocal down for the answer to that one. Cosine now is going to be the adjacent side. So from angle A, if I go over to this adjacent side, I get the 5. The hypotenuse is 13. And so my secant is going to be the reciprocal, 13 over 5. And then tangent is that opposite over the adjacent. So the opposite side is 12, adjacent is 5, and so we have 12/5, whereas cotangent then will be 5/12 for it. All right, now let's do the number 2. Now this one involves a little more calculation. So when we do this one, we're going to start with taking, to find E, we're going to do the Pythagorean theorem for that. So the Pythagorean theorem we're going to take, and we're going to do E squared is going to equal 8 squared plus 6 squared. So that's E squared is going to equal 64 plus 36, which gives me 100. So E is going to equal 10. So I'm going to just put that on my diagram here. One lesson you need to learn is that using your diagram as much as possible will be helpful. So we're going to have E equal to 10. Now to get the measure of angle D, I'm going to have to use my inverse trig functions. So to do this one, since D, we want to use this is an important idea, is whenever possible, use original numbers, okay? Now that's because you don't want to round upon rounding. This 10 we didn't round, so it's actually not a problem with this one, but oftentimes we have to round that side. So use original numbers when you're trying to calculate this whenever possible. But in this case, we're going to go ahead and use the 6 and the 10. So that's tangent. I'm going to do the inverse tangent of that 6 over 8, that side of 8, the leg over the leg. And when I do the inverse tangent on that, I get about 36.9 degrees for that. So this is 36.9. Now, here's where we're going to kind of give an exception, whereas when we've got this, want to find this angle F, you've got a 90-degree angle, you've got this 36.9. We'll go ahead and subtract from 180 to get that other angle. And when we do that, 180 minus 90 minus our 36.9, and we get that equal to about 53.1 degrees. So those are our answers to our 2 opening problems. So our next step is to talk about moving into the word problems with these right triangle trigonometry problems. And oftentimes they involve either what's called the angle of elevation and the angle of depression. Now we talked about those in the last lesson, but I want to talk to you about what to do and to avoid with angle of depression. The first thing to do is make sure you draw a diagram. And drawing a diagram means you're going to draw a horizontal line to start it, and then after that you're going to go down from that, whatever angle you have, to get the angle of depression. So this is the angle of depression. Now, what we'll avoid by doing that is, let's try an example. If I want to do an example like this where I do an angle of depression of 21 degrees. Let's start by doing our horizontal line, and then 21 degrees comes down about that far, and we draw our angle here of 21 degrees. Now, what you want to avoid, and I'm going to draw it up here so that just to point it out to you, where people oftentimes make the mistake is they will oftentimes put the 21 degrees here rather than there. Notice that this is with the vertical, not with the horizontal. So you want to avoid putting the 21 in this spot. It has to go in that spot where it goes from the horizontal going down. It's important to recognize that because we can also use, if I draw in here, a horizontal line here that's parallel to this one, notice that we've got alternate interior angles, a little geometry review. You can put it down here, and notice that if you put it there, 21, 90, 21 don't add up to 180. This number here actually needs to be the complement of that number, so it really has to be 69 degrees instead. So be careful about that. The 21 degrees goes here, or it goes down here in the alternate interior angles, or in that spot you have to put the complement. Let's move on to doing the word problems on the back side of your note sheet. So the first example says a plane is flying at an altitude of 12,000 meters. Let's go ahead and draw that on our diagram. So we put the plane up here, and then we've got the plane above the ground at 12,000 meters. So we'll draw that in our diagram right away. From the pilot, the angle of depression to the airport tower is 32 degrees. So from the pilot in the plane, we draw horizontal, and then down here there's a tower. Okay, so I'm going to just draw a little tower there. You could just put an X if you'd like to. And from the plane, the angle of the depression down to that tower, so this angle here from the horizontal is 32 degrees. So now what we have is some information that we can start setting up triangles. Notice I can draw this here, and I can transfer this 12,000 meters over to this side. So I've got a right triangle here. What it wants us to find is how far away from the tower is the point directly beneath the plane. So directly beneath the plane is here, and so we want to find this value here. And so that's also this value up there. So I can either use this triangle here, or if you want to translate the information into this triangle, you could do it there, remembering that this is also a 32 degrees that you can use. So now, when we've got this 32, and we have the opposite and the adjacent, we can use our SOHCAHTOA to say that that's a tangent problem. So it's going to be tangent of our 32 degrees is going to equal the opposite side, 12,000, over the adjacent side, which is x. Now, to get the x out of the denominator, you multiply both sides by x. That will cancel it just like we were doing in that last chapter. So we have x times tangent of 32 degrees, and we're left with only the 12,000 over here. That got rid of the denominator, just like we did in solving rational expressions before. Now divide by tangent of 32. That tangent of 32 we can do on our calculator. And so we do 12,000 divided by tangent of 32, and that gives us about 19,204 meters. That's about as far from the tower is from the point directly below the plane. So that's an angle of depression problem example. Now let's try the second problem here. This one is going to involve both an angle of depression and an angle of elevation. So what I'd like you to do is I'd like you to try reading the problem and pause the video and try drawing the diagram. See if you can come up with the diagram from what it says, and then we'll try doing it together to compare. Now that you've tried that problem, let's go ahead and set this up. What we do is we want to set up the diagram by saying Fran is standing on a tower, so I'm going to draw a tower over here. So Fran is right here, and she's facing a building. Now that building, we're going to find out, is going to be where she looks up at the top of it and looks down at the bottom. So that means that the building's taller than her. So the base of the tower is 88 feet from the base of the building. Fran looks up at the top of the building with an angle of elevation of 20 degrees. So from here, the horizontal, she looks up at the top of the building. So we're going to say this angle of elevation going up there, that angle is at 20 degrees. So that's right there. Okay, so that's the first part of it. Now the second part of it, it says that on this one, it says that, and down at the bottom of the building with an angle of depression of 29 degrees. Now remember, when we draw this, don't put the 29 here. It's from the horizontal looking down, and so the 29 degrees goes right in here as part of that problem. Okay, so it says, first of all, how tall is the building and how tall is the tower? I'm going to work on the tower first. And the way we're going to do that is we're going to draw this triangle here. This blue triangle here is the one I'm going to look at first. And notice I've got an angle of 29 degrees. This side of 88 feet is parallel to that one, so it's also 88 feet. What I don't know is this value here, that's x. So what I'm going to do is set up a trig function. The trig function is using the opposite and the adjacent, so tangent of 29 degrees is going to equal x over 88. Now all I have to do to solve for x is multiply by 88 on both sides to get rid of that denominator. And so 88 times tangent of 29 degrees equals x. When we multiply that out, we get that x value at about 48.8 feet. So that's as tall as the tower. So I'm going to put that over here. The tower, this tower over here, is about 48.8 feet tall because this height and this height is about the same. Now, let's do the other part of the problem. To get the building, we also need to find out how far it is above this part. So I'm going to call this y and work with this triangle here. So that one also has an adjacent side of 88. So we're going to do tangent of my 20 degrees is going to equal the opposite side y over the adjacent side. 8 is still 88. Multiply by 88 on both sides to get rid of that denominator. So 88 times tangent of 20 degrees is equal to y. Now I do that on my calculator, and if I estimate that on my calculator, I get about this value, about 32 feet, if I round it. And so to get the whole building, I'm going to take x plus y, 48.8 plus the 32, and so I get the building height at about 80.8 feet. So that one involved both angle of elevation and angle of depression. So what we need to do is, the important thing of doing this is drawing a diagram, and then when you're doing angle of depression, make sure you go from the angle of depression from the horizontal going down, rather than in this spot, it goes in that spot, and then you can solve your problems.